Group of engineering students construct a potato cannon. The height, h in meters, of a potato, t seconds after it's shot from a cannon that is on the roof of a building is modeled by this equation. How high is the potato after 1 second, and then when does the potato reach its maximum height? What is it? This is simple. When you're given an equation, and the question is asking, how high is the potato after 1 second? It gives you 1 second as your time, right? You can just plug that in there. This is how functions work. You plug in one of the variables, you solve it, and you get the other variable. So h is equal to -5, 1 minus 2 squared. One minus 2 is -1 squared plus 45. If you're not sure, -1 squared is actually +1. And anything times 1 is just that. So that's going to be -5 plus 45. Final answer is 40 meters. So after time of 1 second, the height of the potato is 40 meters. When does the potato reach its maximum height? What is it? So this is the maximum height. So so if you remember correctly, that keyword maximum, go back to that first example that we did. This is very easy. Maximum height is always the vertex point, or the minimum height is always the vertex point. So we know what the vertex is. My h value is +2, not -2, and my k value is 45. Now, between these, which one is the height, which one is the time? Well, I'll give you a hint. The value that's with t, that's going to be your time. Your h value is your x-axis. So 2 seconds. 2 seconds is the time when it takes, how long it takes to reach the maximum height, and the actual maximum height is 45 meters. That's it. Very simple, especially if the equation is given in vertex form. All right, we got those engineering students. They're at it again. They like to shoot potatoes out of a cannon. How long is the potato in the air? Once again, just to kind of visualize what's going on. We know that this potato isn't starting off on the ground. We know this cannon isn't a ground cannon, or it might be a ground cannon, but we know that they placed it on the roof of a building. So it definitely has an initial height of something. I'll give you a hint. The initial height is this value right here. That is the initial. Oh, no, sorry. I lied. Sorry. This is not standard form. Big mistake there. I apologize. This is the maximum height because this is in vertex form. Had it been in standard form, your C value would have been in. So we don't know what the initial height is. Doesn't really matter. So that's not what the question is asking us. The question is asking us for this value here, right here. And that's called the x-intercepts. We just did an example on this. Your x-intercepts, also known as roots, zeros, solutions. How do we find the x-intercept? Actually, that's a good question now. Because in the previous example, it was in standard form. We could have used the quadratic formula. But now we have Vertex form. Oh yeah, flashlight. Well, I'll give you hints. Standard form means that the height. I apologize. When they're asking us to find the x-intercepts, that means the y value, or in this case the height, is going to be equal to 0. So we know that height is 0. So 0 is equal to -5. T minus 2 squared plus 45. Let's solve this. Boom. The 45 moves over, so now we have -45. Divide both sides by -5. And the order in which you do this is very important. It's kind of like BEDMAS, you know, when you multiply, add, subtract, divide. So yeah, so you have to move that 45 first, then you have to divide. Cancel, cancel. 45 divided by 5 is 9, so 9 is equal to t minus 2 squared. Now to move the square over, what's the opposite of a square? It's square roots. You haven't figured that out. This is basic algebra. So it was plus 45, so now it's -45. It was times -5, so now it's divided by -5. Now it's squared, so that's becomes square root. And square root, whenever you take the square root of a number, remember you have a positive and a negative value. So at this point, you're going to split your equations into 2 to take into account those 2 different possibilities. So square root of 9 is 3, so you have positive 3 is equal to t minus 2. We have -3 equal to t minus 2. Then you just bring this over. And here you're going to have t is equal to 3 plus 2, which is 5. Or, yeah, I'll show this one because this was going to trip students up. When I bring the -2 over, the -2 becomes positive. Not that -3. I've seen students write that -3 as a positive value for some reason. The 3 didn't move, nothing happened to it. Why are you changing its sign? It's the 2 that moved. So 2 became positive. 2 minus 3 is obviously now -1. And these are my 2 x-intercepts, 5 and -1. This is 5. How long is the potato in the air? 5 seconds. Remember to reject this one and write that final sentence statement. A construction worker drops a wrench. Its fall is modeled by the equation given here. How far above the ground was it when it was dropped, and how far has the wrench fallen after 5 seconds? So, how far above the ground was it when it was dropped? So this is the initial height. Because the starting, it starts in the construction worker's hand, and he obviously, he drops it. So, what's that initial height? Well, depends. What form is this written in? Is this written in standard form, vertex form, or what's the other one? Factor form. I'm gonna. All right, let's see what the half that did respond say. 2 of you said standard form, 1 of you said vertex, 3 of you said factor form. Not bad. So this is standard form. So for those of you who got standard form, congratulations. How is it standard form? Remember, standard form is in the form ax squared plus bx plus c. And this is your C value, and this is your first value. But what about that middle value? Well, what if my B value was 0? If this was 0x, would you write 0x, 0 times x? No, you wouldn't. It'd just be blank. So this is the scenario here, where your B value is 0, and you really only have your first term and your last term, your A term and your C term. So just remember that this is a standard form, and it's very easy from the standard form to find the initial height. It's just your C value. So A, the answer is the initial height, or, the initial height's fine. Initial height is 342 meters, or the height was 342 meters when it was initially dropped. B, how far has the wrench fallen after 5 seconds? Well, they gave us the time. It's 5 seconds, so t is equal to 5. Just plug it into the equation. So what is the height? Height is negative 4.9 t squared, but obviously we know t is 5. Very simple, just do 5 squared, which is 25. And then obviously times that by 4.9. Don't forget that negative sign. So the height at 5 seconds is 219.5 meters. Is the question asking for the height at 5 seconds? The answer is no. It's not. It's asking how far has the wrench fallen? Meaning from the initial height of 342, it went to a height of 219.5. So how far did it fall? Just subtract those two values. Very important to read what the question is actually asking. Otherwise, you can get in trouble. And the answer is the wrench has fallen a total of 122.5 meters. That's the answer. Hopefully this makes sense. Question asking how far has the wrench fallen after 10 seconds? Once again, we've been given our time value. These are one of the easiest questions. When they give you a point, just plug it in. Solve for height. You know 10 squared is 100, and 100 times anything, you just... The answer is negative 148 meters. Interpret this information. All right, so what do you think? We're getting a height of a negative height. Is that possible? Is it possible to have this wrench that fell on the ground? What's the lowest height that we can have? 0? Question mark, maybe? I don't know. Let's think about this. So there's two ways to answer this, in my opinion. I mean, obviously I could be wrong. There's probably more